What? Hello? Okay. Well, I've been hard at work since last time. I tried to stream last night, but it seems like it didn't come through. So, I don't know exactly what happened there. But I didn't get very far. So, with that, I'll go over the changes that I've been making. So, I did the entire NBT reader and writer yesterday. That was kind of the big thing that I was able to get done, and I'll go over that in a second. And I've also started working on the packet reader. So, I'm still working on the packet reader. But with regards to the NBT reader, the key thing that I remembered with regards to like learning Rust is that you can have values inside enums. And so this makes it possible to return or to have like an NBT value type like I have here, which can correspond to all the different types of values there are in NBT. So that was kind of the key learning thing there. The other key learning thing for me was you can like, or just the trait system, like you can, it's like mixins, or actually no, I don't know if it's quite like mixins, but you can implement different traits into certain types like this. And that makes it interop with like the rest of the Rust ecosystem, which is pretty useful. So, I mean, I say this is not the most crazy stuff, to be honest. So, this is not the most crazy stuff, so I don't think I'm going to go over this in depth. I mean, it's just a reader and writer. And you know, the reader works, and the writer is the opposite of the reader, and that works. And we have some tests, so we can run the tests. Oh, it's not going to work though, because it's not going to compile because I'm working on this thing. Well, we'll work on this thing then. So, I'm kind of thinking that this is going to be like the main packet reader. So, we're going to be able to basically take in any stream, have it read the packet, whether it's compressed or not, and that will hand it off to some kind of network or net handler. If you look in the Minecraft source, what they've done is they've just had like a giant net handler of like all the functions, and you get all the packets and you handle them. And so I'm kind of thinking of doing something like this. And especially, or one of the reasons why I think this is actually, or could be a winning approach, is because then we can just swap out the, you know, if we call it the net handler, we can just swap out the net handler for a different one. So like we can have a net handler for protocol 47, which is Minecraft 1.8. Or we can have one for the latest version, and we can just switch between them instantly. The only thing that would have to change in addition to this is like some of the game logic and like the renderer. So I think this is kind of a winning approach. But this is a long ways away. We have to implement all the packets first. So that's not yet. So I'm kind of thinking of doing something like that. The problem right now is that, well, the first problem that I fixed, and this is the thing that I learned with Rust, is like how to do these generics. Like generics in Java are not the same as generics in Rust. And generics in Rust are kind of weird. Like for example, we have this, our thing here, but you'd expect this to be the exact same thing, but it's not, and this doesn't actually work. That is, substituting the R, which we said was IO read, directly into the function here doesn't work. And I have no idea what the technical difference is between the two. So that's something I think I'm going to put off for now. Like I'll learn it in the future, but I know it works now, so I think that's enough for me. So I think, and so the reason why I ended up doing this was because I had the packet reader, and when this was a box, it was getting directly, so the reader was getting directly moved into this packet reader. And so when you're doing a compressed packet, or when you're reading compressed packets, I created this gzip decoder, which is from Late 2 library, which just implements IO read, so it makes it really easy to just put it right on top of the other reader and then put that reader into the packet reader. But when I did this, reader was already moved up here, and so this function no longer had ownership of it, and we couldn't use it here. So I had to figure out that you would have to, or I knew that giving it a mutable reference was the way to go because it's the only way you can do it. But I didn't know how to make this a IO read. And the solution is, I guess you just put it as a generic here. So that was kind of a big, that was somewhat of a big discovery for me. It's gonna, I think, well, I guess that was kind of a big discovery because I moved, so I also deleted packet reader, which is what I'm gonna get to soon, I guess. So that's kind of where I've left the work. I deleted packet reader because we're gonna need a way to, or what is the reasoning actually? Oh, I remember. So you actually get the entire packet length right here. So in the protocol, if we look at the, where is it? The packet format. Here it is. So the packet format, you can get, so you get packets that are compressed and packets that are not compressed. And in both of them, the first thing that you get is the packet length. So why would I read each section little bit by little bit and not just, and have like a gazillion read calls per packet, when instead I can just take the up to 5 it takes to read the varant and then read whatever this is and parse it later, right? So it's just less read calls. This would be max 6 read calls versus, maybe like 30, right? So that's kind of important, I feel like. So, and I think it will make things, actually no, it really doesn't make things simpler, or I just have to figure out how. But what I'm thinking of doing is I'm going to just wrap, or I'm going to put all these methods inside this packet buffer and really make this packet buffer like a true buffer with a position that you can reset, etc. And so when all these functions are in here, then we can just load, or what I'm thinking is we'll have this static read varant just as it is because we need that logic. And then once we have the packet length, we'll do like, oh, you know what? That's going to be a problem for the compression. Okay, we'll figure that out in a minute. But we're gonna have this thing, and then we're just, after we read the packet length, regardless of where it is, the packet length is just the remaining amount of data to read. So after the packet length. So for an uncompressed packet, it's right here. It's just the packet ID plus, it's the entire rest of the packet. And for non-compressed packets, that was non-compressed packets. For compressed packets, it's also the entire rest of the packet length. So the data length, and then all of this, right? So we can just read, well, what we would do, I think, is we would allocate a packet buffer like this. And we can say, like, we can make a thing that says, like, with capacity. Then it would be, yeah, capacity. We can make this, and then we can have this buffer be buffer vec with capacity. And so we can have that, and then what we can do is we can make this with capacity and make this the packet length. But okay, this has to be a U size. And then we can just do like reader.read exact right into the packet buffer. But this isn't going to work, I think, because this is going to cause some issues. But we would do this, and then we would do like packet buffer dot read varint, and then we would get the data length. And then we must have to enable, like, we should make a function that says like enable compression. And then we would do packet buffer dot read varint, and this would be the packet ID, right? So this is, I think, a better way of doing it. Again, we're going to have like 6 read calls at most from the socket, so it should be faster. So with that, let's actually go and do this. So we're going to get all these things here, get them moved into here, and then we're going to have to drop the reader, we're going to drop the reader because we don't need it anymore. It's just going to have a position. Or you know what? I wonder, can you make like a custom buffer in Rust? Let's see. How do we do that? Okay, so you do have to, or you would make, okay. All right, so I guess we would have like a position right here, so. And this would just be 0. And then this would be 0. Or you know what? You know what, let's just start with this. We'll move all these functions in here, and we'll do that. We'll see where we get. What the heck? It's not what I want to do. Let's do one at a time, I guess. So now we can drop this like IO read thingy. We can say .self, and this might not even be a result, possibly. We would just have to let me think. It would just be like buffer Yeah, we would need a position thing, but we would say like self.position if as U8, and that's it. Right? Yeah, that's an easy one. And then read bool would be same thing, except we can actually just copy this. So we don't need the OK because this is not. Oh. Or this can just be byte. This can just be equals 1. That's it. That's the entire function. And why am I doing this? I'm deleting these. I don't want to be deleting these. Wait, so I'm going to do this. Oops, that's too much. There we go. Yeah, so you don't want to delete those functions because these do have a purpose. Yep. And then we would want to do, I feel like we should have like a read. This would be a private though. Right. Yeah, we can just do like a, or we can just implement read byte array. Then we can use this. I'm not sure what the type is going to be yet, but it's going to be like a slice or something. And we need to increment the length after this. Oh, the rest isn't going to let us do that. So we'll do this. So yeah, can't forget to increment the length. Otherwise it's going to break. And can't do that with Rust, can we? Why is this audio getting to be so bad? Okay. So we'll have like a read byte array, and it'll be self.position to, and then when you're taking a length, usize, self.position plus usize, or length. And this should, yeah, this should be a U8, but we don't want it to own it, it's just a reference. Or is it not? Yeah, that's what I thought. So, there. And the result. And then similarly, we need to increment the position by length. And return the result. And the reason why we can do this is because this is just a reference to a like it's not going to, this isn't, self.buffer is not going to get dropped after this function ends because it's part of the struct, so it should work. So maybe we can change this to like, actually no, that doesn't really need changing. So we'll do here, read byte array 2. I think a better way to do this. No. Okay, well, read byte array 2. And I wonder if we can like somehow make the length of this. Or can we tell Rust like the length that this is going to be? Because, oh no, I don't think people will be able to. But it's okay. Yeah, because this is going to expect. So can we do this? And this is going to be U8, 2. Well, I guess we can also do this. 216 BB bytes. There, we can just return where this is the results. And again, there's definitely a better way to do this, but I'm more concerned about learning and getting practice with Rust, so we'll come to all the optimization stuff at some point. And these are just going to be a bunch of copy-paste kind of functions, except they're integers. Oops. Three, 4. And then honestly, let's just have, I'm tempted to just have chat complete the rest of these since I don't think this is really the best use of my time here. We'll do that. And so in the meantime, it's still going, right? Yeah. In the meantime, we have to figure out, or we need to do that enable to compression thing. So let's look at how, or what Flake gives us here. And we want a zlib actually, so this is not, that would have been not correct. Because if we look at the protocol, zlib compression is enabled. So gzip would not be right. Yep, this looks good. So now we have that, except I don't like this. This is like super confusing, but it's okay. That should be fine. So now what we want to do is, I think I'm going to create a packet buffer. No, not yet. We're going to read the packet length and do this, and then somehow we need to read all of this into this packet buffer. So we're dot buffer, and we need to give this a mutable reference. Oh, okay, that does work. And I know it's safe because it's Rust. So, okay, so we have this, and now we need to do this enable compression thingy. So, in the zlib decoder, new with buff, perfect. It's exactly what I needed. Oh, wait. I don't know if this is what I want. I definitely want to switch how I'm implementing this to something else, I think. Like, this is basically a buffered reader, kind of. Not really, actually. Well, I don't know. We just need to, let's make this, you know what we need to do? We need to do implement IO read for packet buffer. That's what we need to do. And then we're going to say read byte array. And then we need to figure out how to insert, or I don't know how to do this in Rust, but we need to set this, or we need to like move this reference into this reference, but this is going to be kind of weird. So just like buff equals this. Like, how do you do this? Let's ask. Yeah, so we can learn. Nope. Yes, it won't compile. Problem tries to reassign a mutable reference to a parameter, which doesn't allow. Also, result is a yes, and that is this different types. Correct information copies the bytes into the routed buffer. I see. Okay, so you just have to know that function. And with that, then we'll make it. Then we'll be able to do this. Oh, you know what? If we do this, wait. We can totally do this. Like, since we've implemented IO read, now we have access to like all of these functions. So that could be like a whole lot of like, well, you know what? These are kind of nice because they're guaranteed. So well, actually, you know what? What happens if it's like a varant? It's, yeah, we would panic and we don't want to do that. So actually, let's refactor this a little bit and let's make, first of all, we're returning here. We're returning a vec, so I don't want to do that. But yeah, let's do a quick refactor. And let's just self dot read byte. And what we'll do is we'll create a like a simple reader, like a dummy reader in Rust. No, I want like a cursor. Yes, this is what I want. So, new cursor. Well, hold on a minute. Let's pause on that. Let's delete that. Subject U8. Yeah, we don't want a U8, so we'll do it anyhow. Results U8. And then we need to figure out how to get this reader, and what we'll do, or what I'm thinking of doing, is just having like for buffer reader, and this is just going to be AR. Wait, how do you do it? It's like do it there, right? Okay. It's going to be a reader, and then this is going to be, but you do this here. It's going to be an R, and it's going to be an R, and buffer, or buffer reader. No, you don't do it here, what am I saying? Buffer reader is going to be a cursor. And that's going to be self-dot, or let's just see, what does cursor actually implement? No, so we want to do like a oh, how do we do this? We can say self.buffer, but we haven't really initialized it. And does cursor not implement reader? Or IO read? I'm just worried that if we do this, we're gonna lose like the reference kind of. The reason why I want this is because we're going to need some kind of a cursor, right? And then we're going to need the the zlib decoder on top of that. Like we need a reader here to say this can stay the same. We just need to make this an anyhow result. Like we need a self.reader here. And then we're going to give the cursor as the reader and the writer. But it doesn't work. Which makes me think it doesn't actually implement the thing. I'm going to delete this with capacity temporarily. And this does need to be this needs to be this, and this. Oh wait, yeah, we don't need to do that here. So now it's just this reader. Oh, whoops. How do we set this reader kind of thing? I think this is another thing we just gotta know. So we're gonna do this. Okay. Problem is value ownership. When you sign, it moves. No. Well, that is an issue, actually. We need to make it a box. No, we're not. We need to do a reference or something. No, we're not. We need to make it an arc, or I don't know. Okay, let's just have let's have AI finish up these again because it's a bit of an annoying process. Whereas I'm just blind apparently, or it's just not here. We'll do both. We'll say, well, I don't want to really fix it. I want to figure this error out. No. No. No, I want to do it this way, I think. Say, is compression enabled? Cool. And then we're going to say self.reader equals glib decoder new. Then we're going to give it the uncompressed reader, the cursor. That might not be right, but it's okay. Let's see. There we go. So we have the packet length up here. We're going to create the packet buffer with whatever length at some point. Yeah, I guess this is how I'll do it. This would be data length then, after we get this packet buffer, and then we enable compression. And this would then be the packet ID. And then we'd have the packet data. Similar thing here. You can actually just do this for both. If they both start with a packet length. We just need this with capacity, and this needs to be packet buffer. Perfect. Looks great. Okay, so now we're kind of left with this error. And read packet. We get the packet. We want to give it the packet buffer. But we'll hold off on. Just delete this for now. So we can. The reason why is, and we'll delete this too, is because. Oh, okay. It's because I want to have the cargo output. Oh my god. Result. How we do anyhow result. Dang. How about then we replace anyhow here with IO, since it'll all be IO stuff. Grr, this is so annoying. What we'd want to do. Let me just do how do we do error formatter? Search up Error formatter, Rust, error formatting. This is so annoying. Like, this is I think one of my nits with Rust. Like, it just seems like errors for whatever reason are so unnecessarily like difficult. There's not just like universal error types that everybody uses. Like, everybody has to make their own error type, and I don't know why. Kind of annoying. Okay. Right, so that doesn't work. Or do I need to make this an IO error? Is that the thing here? Is this the problem? Okay, so you can't do that. Or it said something about an error kind. I see. Let's see what it will do. How we say, we tell AI to do this, and we'll see how it does it. How would you return an error in read bar long and read print? Okay, so this is how we do it. Good to know. So you just gotta know a lot of it. Like, you just gotta know it. If you don't know, you don't know. But now we can't use this error, see? Like, is this not the most annoying thing ever? Now we have to do, like, all of this. Or if you do if okay string or I guess we can just do a match. Then okay. String error. Then we'll do IO error. New, and then IO error kind, invalid data. Invalid string. GFP data. Sure. Then we should do error this. Okay. That's looking better. Here in cargo build. Perfect. So now we're getting these errors, which is what we want. Oh, except for this one. Yeah, we're not there yet. It's just, honestly, let's just do that. Okay, finally, we have just the arrows we want help with. Let's create a new thing. How would you solve these errors? Learning Rust. Okay, let's see what it says. Taking its sweet time thinking about it. What? So we created 2 new vex. How about no? Holy crap, stop. Okay, this is just getting insane. We're gonna undo this, and we're gonna ask good old Claudius. Same question. Hold on. Use cloud code. Save. Okay. Let's see. Hmm. I guess so. Yeah, that's a fair point. This is especially a fair point. Alright, so we can do that. So what we'll do, whoops, is we will drop the cursor and we'll add the buffer back. Drop all of these generics because we don't need them. And then decompress. Yeah, you can just do this. I think this is fine, we know how to do it. Well, actually, let's do it ourselves. Let's see. Position, size. And so then this will just decompress the entire buffer. So we will say dlib decoder new what does it recommend doing? Okay, create a new. It's gonna say read exact or read to end. Sorry, this is gonna be. I see. Back new. And then this is going to be a call to the decoder. Read to end. Coded. And so we need to return. Is this the result? Yeah. So we'll do that. Then stop buffer equals the coded buffer, and we'll reset the position. Okay, all right, I guess that makes sense. And then compress will be similar. And then I think this will just, I think it's fine. You just have to re-implement IO read. Yeah, I figured I should do this, but I did not. It's a good call by Claudius. So we'll do that. Because what would happen if with before is it might read over the buffer and that would cause some issues. You don't want that. It would be like an index out of bounds kind of error. They go with the entire file? Yeah. All right. This song that's playing now brings me back to like, there's a game on Scratch called Make Your Own 3D World. It's from 2015 or something like that, or 2013 maybe. And I remember as a kid in elementary school, or something like around that time, just like playing this game, and I remember this music so vividly. All right, there we go. So that's that. We can now, what I'm going to do also is I'm going to do actually, I'm not. We're going to do this, we're going to get the reader, get this, create the thing, and then decompress. No. I'm going to do this one, well, hold on, let's go back here. I forget already. Yeah, it's not compressed, so I'm just going to read it. Well, yes, we can do this because decompress goes from the current position and on, so it will work. All right, perfect. All right, so that's really good. That's kind of working that, or that's all set up. So read packet, we don't want this to be mutable. And write packet, we do. And then we're going to have like a packet registry. And there's going to be a match. And then we'll read the packet depending on the thing. All right, so that's good. So now we're just going to have to create all the packets. So I guess we'll start, or we'll do handshake. And there's only one packet for handshake, I believe. Yep. And we need to add this to here. And we will implement this. Or we'll implement packet reader or packet read for this. And then we'll do reader.read varant. Beautiful. Look at this. This is awesome. This is so easy now. This is what happens when you set your code up well. It just becomes super easy like this. Whoops. I say that and then report. That's becoming a U16. And the connection state is a read varant. I guess this does have to be mutable, actually. So we'll go back to packet and make this a mutable reference. And I'm going to rename this to buffer. I don't even know, I don't need to implement that actually, because this is a client packet, right? Or client bound? No. This would be server bound. So we need a write, but not a read. Well, it's gonna get it there. It's gonna get it anyway. For the other ones, we don't need it. Yeah, I think we'll just, this is an easy, just clone. And that's all the handshake packets. And so, you know, I'm just gonna delete this even though I wrote it out. And now let's do login. Where's the login packets? Ah. Now, I know I could probably use a macro for this, and I'm kind of considering it because this is already really tedious. Oh, that's login success. I'm looking for login start. Why don't we can just do a status packet instead of login. You can do the status packets. Oh, whoops. What the heck? And then we can test, that's actually testable easily. Status client. Oh, and you know what? These need to have packet IDs. So hold on. We need a write packet function. That's what we need. Let's do a write packet function. What the heck is going on with YouTube Music? I just have to play music from my local files. Or maybe we can let's do this. No, it's still not working. For whatever reason, YouTube Music is acting up. There we go. Making inspired. And we also are going to need the packet we want to write, so that would be probably helpful. Now, somehow we need to add like the packet ID here. So can we add a variable or field packet ID? Let's see how it does it, and we'll just copy it in the future. Should be one line. One line. They've made this so much worse over the past while. This used to be like you get an answer instantly, and now it does all this other junk. in the background. Like, no, it's not what I asked you to do. Oh my gosh. No. Let's just search it up. Packet ID in a field in a trait Rust. Well then, how do you have like a I guess packet ID. But I don't like how did what I'm thinking is like doing something, where was it? Something like this, where you have like a type. Oh, you know what? This is a type, that's the difference. Yeah. Okay. Well, in that case, we'll just do a packet ID like this. And then packet ID is a varant, so we'll make this I32, I guess. So, oh, I don't want this to be a packet right. I want this to be, actually, I do. Yes, we're going to do this. And then we're going to have and then we're going to have, if it's compressed, we're going to write the data length, which is, what again? Length of the uncompressed packet ID plus data. Okay, well, how about we just do this then? Okay, yeah, we'll do this. So, packet buffer dot write varant, and then we want to write the packet ID, and then we're going to write the rest of the thing using the packet itself. And so what we have now, or else, if we don't have that, we just need the packet ID in this, but we need to write the length. So we'll do like, we're gonna have to have like three buffers here. Packet data buffer, we'll do that. This is the packet data. And so then the final, then we can have like a final or packet wire buffer. And then we'll do write varant. Or we can just do this, I guess. It's not that big a deal. Oh, you know what? We don't have the write methods outside it. So you would have to, well, and that kind of raises a thing, like, I think we should just move. Yeah, I think it would be better if we, yeah, let's do that. I'm gonna have Claude do this. It'll be faster. This is just refactoring. Please move the, or just like the static, like top level read methods, create the same for the write methods, all of them taking a writer, or taking IO write as parameter, then wrap them in the buffer struct or impl, just like read. Also implement write or buffer. That'll be faster. Let's see this bug potentially. Oh yeah, that is a bug. How do we solve this before? This happened before as well. Because the reason why this happens is because when you do with capacity, it creates the oh, I remember what we did. It creates the capacity, but it doesn't set the length. It sets it to 0. So when you try to do read, it thinks it's at the end. There. Fixed. Yep. And yeah, I guess we can do U8 just to specify. Okay, cool. So this is looking better. So now what we can do is we can just say write warrant writer, and then we want to write the packet length. So just make a utility kind of thing here. Or can we implement like, is there like a length trait to implement? Rust does not. Okay. So we don't need to. Just do it right here. So we can do right parent packet data buffer dot length. As I32. And then we'll write writer dot write all this. Okay. And now we need to do this side where we'll write, keep forgetting. And then we need to make a new one here. Compressed packet data buffer. Nice. And then we would need to oh, hang on. This would not be it. Okay, that should be it. Alright, I think those are all edited here. We made a lot of progress. We basically redid the entire packet buffer, but it's a lot better now, a lot more usable. So that's good. And we got the compression working, and we kind of finished up the write packet and read packet. We just need to figure out how we're going to actually register all the packets and make all of them. So that's what we'll do next time. Yeah, we'll maybe see if we can auto-generate them, because this is going to just be so tedious otherwise. And yeah, peace.